Hi, this is the architecture diagram of my application, and the application flow is as follows. So the user interacts with my EC2 instance, which hosts a front-end application. This application provides the functionality of uploading the PDF file and downloading the converted CSV file. So the user uses the /upload API gateway to upload a PDF to the S3 bucket. Now, as soon as the PDF is uploaded to the S3 bucket, trigger runs a Lambda function, and this serverless function performs the text extraction job using Amazon Textract. Textract extracts text and data from the PDF file and converts the unstructured data into the structured data. Now, when the Textract finishes extracting text from the provided PDF, it uses another AWS service, which is SNS, in order to send a notification to another Lambda function. The Textract also stores the response back to the S3 bucket. Now, the second Lambda function, upon receiving the SNS notification, reads the extracted text response from the bucket and converts it into a structured CSV file. This function uses a pandas layer in order to perform the data manipulation. Now, after the CSV file is ready, this Lambda function uploads it back to the same S3 bucket. And finally, the user can call the /download API gateway, which triggers a third Lambda function. This function fetches the CSV file stored in the S3 bucket and generates a pre-signed URL for that particular file and returns the response back to the EC2 instance. Now the user can download that CSV using the /download call on the EC2 instance. So I have provisioned all of my resources using CloudFormation, and now I'll quickly go through the CloudFormation script. So this is my CloudFormation script. It takes a parameter for which is a role parameter, and I have set a default role, which is the lab role. Now let's take a look at all the resources, starting with the compute resources. So we have three lambdas as demonstrated in the architecture diagram: the text detection lambda, CSV generator lambda, and CSV download lambda. The text detection lambda is responsible for generating text job and extracting text from the PDF file. The CSV lambda is responsible for generating the structured CSV file, and it uses pandas as a layer for this task. And finally, we have the CSV download lambda, which is responsible for generating the pre-signed URL for the CSV file created by the CSV generator lambda. Now, these are all the required permissions associated with each lambda function, and this is the pandas layer which I mentioned earlier. Now, moving on to the next compute resource, which is the EC2 instance in my case. So this EC2 instance is used for hosting my front-end application, and this is the script which runs during the provisioning of the instance. So it basically sets up the environment for my front-end application, install all the necessary dependencies, and below are the security group and the profile which are associated with my EC2 instance. Now the second type of resource is the storage. So for storage I have used S3 bucket. Then the third is the network. For network I have used API gateway. Now all in all I have two APIs, one for uploading the PDF and the second for downloading the CSV file. So below are the resource, the method, and the deployment for both of the APIs. Now for general I have used extract and SNS. So the extract is directly used by the text detection lambda, which we saw above, and the SNS topic is basically used to send the notification from the text detection lambda to the CSV generator lambda, as shown in the architecture diagram. And finally, I have used the SSM parameters to store the API deployments so that I can pass the value of the SSM parameter to my EC2 instance in order to set the environment variables, which are basically the URLs for upload and download. And I have used the outputs just to view the values of resources provisioned by this entire CloudFormation script. So now I'll run the CloudFormation script and provision my resources for the application. So I already have the template ready, and this is the default value, the role value. I'll give the permissions as lab role, and I'll keep the other options as default, and I'll keep the rest of the things as it is, and I'll just acknowledge. Click on submit. So now the resources are getting provisioned, and this may take some time. So I'll fast forward the video until all the resources are successfully provisioned. Okay, so now the stack creation was successfully complete, and the status is create complete, and total 76 events happen. And if we look at the resources tab, then we can see that total 23 resources were provisioned with my cloud formation script, and we'll go over each resource step by step. And this is the output which I have defined in the script in order to just view the values of the resources. So now that all of my resources are up and running, and the stack was created successfully, I'll go over each resource step by step. So let's start with the API gateway. So we have two API gateways. This one is to download the converted structured CSV file, and the second API gateway is for uploading the unstructured PDF file to the S3 bucket. Then we have the EC2 instance. So the EC2 instance takes time to set up. So in order to track what's happening on the instance, I have added a log in the script for monitoring, and so I'll check that log to track the progress of the instance. So till the time the instance is setting up, I'll go over the other resources. And yeah, this is the security group which is associated with our EC2 instance. And next we have three Lambda functions. So this is the CSV generator Lambda, this is CSV download Lambda, and this is text detection Lambda. And I'll go over the code in a while. Then next we have the S3 bucket, where basically the PDF file, the response from the text extract, and the converted structured CSV file are stored. Then there is the SNS topic, and lastly we have the SSM parameters, which are used by our EC2 instance to set up the upload and the download URL. So this is the URL. Let's check the progress of our EC2 instance. So the instance is still in progress. Okay, so I guess the EC2 instance is up and running now. Um, but before that, I'll quickly go over the programmatic elements of my application. And this includes the three lambdas, which form the backend of my application, and the front-end code in Next.js. So all of this code is uploaded to yeah. So all of this code is uploaded to term and code S3 bucket. So these are the three lambda functions. The pandas is the library which we have used as a layer, and this is the front-end application code. And this S3 bucket is from where all of the code is deployed. So first I'll go over the front-end code. So this is written using Next.js in TypeScript. So the file list state is used to keep track of the files uploaded by the user. Then I'm creating a props object which is passed to the upload component from ANTD library. And in this prop, we have different properties. The action property is used in order to set the upload URL, which is basically set in the environment variable at the time of EC2 instance provisioning. This URL was stored in one of our SSM parameters. And then we have the onChange function, which basically updates the file list state whenever the files are uploaded. So for now, it limits the list to the last 5 files and updates the file URL from the server response. Then we have the handle download function. So this is triggered when the download button is clicked, and it basically fetches the download pre-signed URL for the CSV file generated by one of the functions, one of the Lambda functions. And again, the download URL is set as the environment variable, which is configured, and this value is fetched from the SSM parameter. Now, if the CSV file is not ready yet, it will show a pop-up saying the download is not ready yet. And finally, if the file is successfully downloaded, the function will reset the file list state. And yeah, lastly, we are returning the JSX code for rendering the component. So this includes the upload component for uploading the files, and there is also a download button, which is which is used to trigger the handle download function. So the overall purpose of this code is to allow users to basically upload PDF files to S3 and also download the converted CSV file. Let's move on to the backend code now. So let's start with the text detection lambda. So the overall purpose of so I have used 3 lambdas in total, and each of them is written in Python. So the overall purpose of this particular lambda function is to extract the text from the PDF uploaded to the S3, and this is done using AWS text track, and also notify an SNS topic about the job status. So the extracted text is stored in the same S3 bucket as a response again. So the function uses a few environment variables, and which includes output bucket name, the S3 prefix, and Amazon SNS topic ERN, and also the role. So first I have initialized the AWS extract and SNS clients in the function. Then I'm extracting the bucket name and the file name from the S3 event, so that we can pass these values in the texttrack job. Now the texttrack job is to basically extract the text from the uploaded document, and the output of the texttrack job is stored in the texttrack response. Now if the job is successful, then it basically publish a message to the specified SNS topic, and if both the texttrack job and publishing the message were successful, then a success response is sent. So this was all about the text detection lambda. Now once the texttrack job is completed, this lambda would send SNS to another lambda, which is the CSV generator lambda. Now, so the overall purpose of this function is to process the response of a texttrack job, prepare a CSV file with the extracted text, and also upload the CSV file back to the S3 bucket. So the function uses environment variables in order to get the S3 bucket name and the prefix. Then this function is triggered by an SNS event. So it basically extracts the texttrack job ID from the SNS message, processes the texttrack response, and also prepares a CSV file, structured CSV file rather, and later it uploads it back to the S3 bucket. So the upload to S3 function uses boto3 in order to upload the CSV to the S3 bucket, and processes the texttrack response for a given job ID, and this logic can be manipulated based upon the business requirement basically. So this was all about the CSV generator lambda function, and the last lambda function is CSV download lambda function. So the overall purpose of this code is to provide pre-signed URLs in order to download the CSV files from the S3 bucket. Again, this function uses environment variables to get the S3 bucket name, and this function is triggered by an event. So it creates an S3 client, and then generates the pre-signed URL using for the CSV file using the generate pre-signed URL function. And on success, it'll send the response with the pre-signed URLs. If no CSV files were found in the bucket, then it'll return a message saying no CSV file found. And if the CSV file is not ready yet, then it'll return download not ready. So this was all about the CSV download lambda function. Now I'll show the working demo of my application. So EC2 instance is up and running now. Yeah, so the application operates on port 3000, and it employs the HTTP protocol. I'll run it on 3000 and it's HTTP. So this is the landing page of my application. Now it's very minimal kind of a UI. So we'll start off by uploading a PDF file. So the PDF was uploaded successfully. Now, but if we attempt to download the CSV file immediately, so we are informed that the download is not ready yet, and this is true because the extract job, which is responsible for this conversion process, is still in progress. Now, in order to track the progress of the job, let's monitor the status, and we'll do that by using Cloud Watch logs. Okay, so here we can see the logs of the Lambda function, and now it says that so until then it was waiting for the extract job to complete, but now we can see that the Lambda function is successfully completed and it has converted the CSV file. Now let's try downloading the file again. All right, so here we can see that now we can download the converted structured CSV file associated with the PDF which we uploaded. Okay, so this is what the structured CSV file looks like. Uh, so in this CSV file, basically each row represents the page from the PDF, and each line in the row. So each line in the PDF file will be is represented as comma separated strings. So this logic can be tailored to meet specific business requirements. Now I'll open the PDF file as well for better understanding. So this is the PDF file, and this is our CSV file. So it will convert each page as a row. So all in all we have total 8 pages, so we have 8 rows, and for each page it will convert the line as a comma separated string. So here we can see that the first line is Dalhousie, so that's the first string in the list. Then we have university, uh, and let's check the last line then. So the last line says use cloud technologies, and as we can also verify that here. So it says use cloud technologies, and let's verify if it's converting till the last page or not. So the very first line of our 8th page says student code of conduct. So the last row, which is 8th row, also has the first string as student code of conduct. And if we check the last line, so the last two lines says that learning and support resources, and please see this URL. So the last two elements of the list says learning and support resources, and the last element says please see this link. So this was all about my application. Now lastly and most importantly, we must remember to delete our the stack which we created when it's no longer in use. So I'll delete my stack now.